So now we're looking at these examples here, and here I'm going to have you find the discriminant, determine the type of solutions, and then decide which way you want to find them. So first off, we've got x squared minus 4x plus 4, right? Now if we are looking at quadratic formula, our a is going to be 1, b will be negative 4, and c is going to be 4, right? Our discriminant is b squared minus 4ac. Right, so b squared minus 4ac, this is going to be negative 4 squared minus 4 times 1 times 4. That will be 16 minus 16. So our discriminant is 0. That means we have one real rational root. Now, the advice that we had from that previous page says that we can use any method we want to solve this. I'm going to show you two different ones because I do want to just point out that whatever method you use to solve it is going to give you the same answer. So let's just start sectioning things off so we don't get everything confused. So the first thing I'm going to try is going to be the quadratic formula. All right, quadratic formula, x is equal to negative b plus or minus the square root b squared minus 4ac all over 2a. You're so welcome. All right, so in this case, we already know b squared minus 4ac. We found that over here. Negative b is the negative of negative 4. That'll be positive 4 plus or minus 0 all over 2 times a, which is 1. That is going to be 4 over 2, which is just 2. Right, so our solution set is 2. And if you remember, this is what we call a double root. All right, but what if I decided to solve that a different way? Let's say I decided to factor and solve. All right, so x squared minus 4x plus 4. I need things that multiply together to give me positive 4 and add together to give me negative 4. Right, that is going to be 2 and 2. Now remember, this is the same, this positive here means we're going to have the same signs, and this here means we're going to have a negative in there. So we're going to have x minus 2 and x minus 2. Right, and again, this is the reason why we call it a double root. These things are going to work out as you see more and more of them. Right? In either case, this means that x minus 2 is equal to 0, or x is equal to 2. So no matter which way we do it, we're going to come up with the same solution. Now if you notice, if we wanted to complete the square, well, we already kind of did, because x minus 2 squared, it's going to be in vertex form. It's just that our value of k is going to be 0. That breaks your brain, don't worry about it. You have two different ways right here that you can find the solution that you're looking for. So let's move on to our next example. All right, I have x squared plus 5x. Plus 5 equals 4x. So that tells me right now I need to do a little math. I need to move this over here. So that's going to give me x squared minus 4x plus 5. All right, so here my a is going to be 1, b is going to be negative 4, and c is going to be 5. So my discriminant, b squared minus 4ac, is going to be equal to negative 4 squared, which is 16, minus 4 times a, which is 1, times c, which is 5. That is going to be 16 minus 20, which is negative 4. Right? This means I have two imaginary roots. All right, so my best way to solve is going to be complete the square or quadratic equation. So let's do it both ways. So let's first try to solve using the quadratic formula. All right, so we've got x is equal to negative b plus or minus square root b squared minus 4ac all over 2a. This is going to be x. This is going to give me x is equal to negative of negative 4. It's going to be 4 plus or minus. We already found out that b squared minus 4ac is negative 4. So we can just put that in there, all over 2. Right? That is going to be x is equal to 4 plus or minus 2 times I over 2. Right? The reason this is 2I is because the square root of 4 is 2, and we have a negative in there, and that is what gives us our I. Right? These are all divisible by 2. It's 4, 2, and 2 are all divisible by 2, so we can simplify this to be 2 plus or minus I. And then just for funsies, we're going to go ahead and solve this by completing the square. Right? So our original, we want to isolate the first two terms. Here, that is going to be x squared minus 4x, because we're going all the way back to here. Right? We leave a little space, and we keep our plus 5. Right? So now we want to take this middle term. We're going to divide it by 2. Negative 4 divided by 2 is negative 2. I'm going to take negative 2 and square it. That is going to give us 4. So here we are going to add 4 and subtract 4. Okay. This in parentheses is going to simplify to x minus 2 squared. 5 minus 4 is going to give us 1. And remember that this is all equal to 0. So this is going to give us that x minus 2 squared is equal to negative 1. We take the square root of both sides. That gives us x minus 2 is equal to plus or minus the square root of negative 1. We're going to bring our 2 over to the other side. It's going to be 2 plus or minus, and the square root of negative 1 is I. So you see, two different methods, same answer. So our solution is going to be 2 plus or minus I. Right. For our next example, we are looking at 6x minus 5 equals x squared. Now again, we're in a situation where we don't have standard form, so we're going to have to make that happen. So I'm going to move these things over here because I like keeping my x squared term positive. So this is going to give me x squared minus 6x plus 5 equals 0. Now my discriminant, b squared minus 4ac, is going to be, my b is negative 6, so that will be negative 6 squared minus 4 times 1 times 5. So that's going to give me 36 minus 20, which is 16. So now if you notice, 16 is a perfect square. So we are expecting to find two real rational roots. Right, and if you remember from the other page, the best ways to find that is going to be to complete the square or quadratic formula. So let's look at quadratic formula. Since we've already done our discriminant, we've done half of it, right? So we've got x is equal to negative b plus or minus the square root b squared minus 4ac all over 2a. Get that in your head. You'll never forget it, and next year's teacher will be so happy with me. All right. Negative b is going to be a positive 6 because our b is negative 6. Plus or minus. Now we already know that our discriminant was 16 because we took care of that over there. And then a is 1, so this will just be 2. So this is going to be 6 plus or minus 4 over 2. Okay. And we can split that out into two different equations. So this would be x is equal to 6 plus 2, which is 10 over 2, which is 5. And then x is equal to 6 minus 4 over 2. So it's going to be 2 over 2, which is 1. Okay. So our solutions are 1 and 5. Okay. Now if we wanted to do this some other way, let's say we wanted to factor. Right? We'll see what that looks like. And if you're saying, Ms. Hudson, you're crazy, I've already solved this, that's fine. This is a good way to double check yourself, and this is just a way for me to show you that no matter which way you choose, you are going to get the same answer. All right, so again, we had x squared minus 6x plus 5 equals 0. All right, now I'm going to factor this. I'm going to notice right here that this means that I'm going to have the same sign in each of my binomials. This means I have to have a negative. So if I have to have a negative and they're the same, I'm going to have 2 negatives. I don't have anything out here, so I know I'm going to have an x here and an x here. Right? Now, I need to find two numbers that are going to multiply to give me a 5, and then are going to add or subtract to give me a negative 6. Right? 5 is prime. Our only options are 5 and 1. But let's just double check that. We've got x squared minus x minus 5. And then these two last terms multiply to give me 5. So we're good. I'm going to set both my factors equal to 0. It's going to have x minus 5 equal to 0 and x minus 1 equal to 0. This is going to give me x equals 5. And this is going to give me x equals 1. So no matter how I'm solving it, I am coming up with the same thing. If I decided to go ahead and complete the square, I would also get the same thing. I'm not going to do it because I don't have the space, and I think I've made my point.